Runnable classes are used for building chains. LangChain offers multiple runnable classes. You will learn about the runnable classes and runnable config class in this lesson. You'll also see many of the commonly used runnable classes in action. In the last lesson, I introduced you to the runnable interface. All components that make up a chain implements the runnable interface, including the chain itself, which means that all components and chains expose these functions. In fact, you have already used these functions. There are some common attributes as well. The input schema and output schema are pydantic schemas that describe the input and output for the chain. Then there is configuration specification, which holds the list of configurable fields for the runnable. At runtime, you control the behavior of these functions by passing an instance of the runnable configuration. Runnable configuration is an optional argument to the functions. To give you an example, you can specify the maximum size of the batch by setting the maximum concurrency in the config instance and passing it to the batch function. LangChain provides multiple types of runnables that are used for creating the chain. The illustration here shows the most commonly used runnable types. Let's go through each one of these one by one. Runnable pass-through takes no action on input by default. You can use it for manipulating the input-output keys using the assign method. Runnable pass-through is commonly used in combination with other runnables. The next one is the runnable lambda. Runnable lambda allows you to wrap any Python function with the runnable interface, which essentially means that you can call any Python function in a chain. It is commonly used for building application logic. For example, you can validate the value of the input variables before sending them to the LLM. The runnable lambda doesn't support streaming. A call to the stream function internally executes the invoke function. Let's try out the two runnables that I have discussed so far. The code that I'm showing you in this video is available under the LangChain folder LCEL Runnable Basics. You can also try it out in Google Colab. The Open in Colab button is available under the section LangChain on the page titled Chains LCEL. I'll first show you how to use the runnable lambda. Start by importing the runnable lambda class. Now we need to define a test function. So I'll just say def add1. It'll take an input which will be of type int and it'll return a value of type int. Here in this function, I'll simply return x plus 1. So we'll wrap this function with a runnable lambda. So add one runnable equal to runnable lambda and pass it the function that we want to wrap, func equal to add underscore 1. So this will create the add one runnable, and let's just invoke it. Call the invoke function on it with an input. Input is 1, and as expected the value came out to be 2. Let me show you the runnable pass-through in action. Start by importing the runnable pass-through class. We'll first create a do nothing runnable, which will be an instance of the runnable pass-through class. So this will have no impact on the inputs. To test, I'll set up input equal to a dictionary with two elements a and b, and we will simply call invoke on the do nothing with this input. And as it's a do nothing runnable, there will be no impact on the output. So output is same as the input. Now we are going to create another instance of runnable pass-through, which will add a new key to the input dictionary, and the name of the key will be C. So we will start by declaring a variable add new key runnable equal to runnable pass through, and to create a new key we need to use the assign function on the runnable pass through class. So here I'm passing C as the argument, so this will become the name of the new key, and to assign a value we need to use the lambda with input, and in this case let's assign a fixed value of 3. And now we have a runnable which will add a new key to the input. The name of the key will be C, and the value for the variable C in the input will be set equal to 3. Let's go ahead and run it. .invoke and pass it the input. And as expected, now you see there is a additional attribute added to the input.